Here's a problem I want to go over, and actually it's a 10-part problem. I actually printed out the problem from my math lab, and I just want to talk about it. So what this is, on the actual my math lab, this is like a matching problem. You notice here are 10 different graphs of either cosine or sine waves, and then above it are 10 different equations for either cosine or sine graphs. And what happens is each of these equations correlates to one of these graphs. And when you do this problem online, you're going to grab, whenever you decide which graph is the correct one for this equation, you grab it and pull it here. And then when you decide which graph is correct for this one, you grab this one and you place it here. In order to explain how to approach doing this kind of problem, what I have done is I've gone and sort of made a list of all the different equations that I'm going to match the graph to. So you notice here I also have 10 equations. And then what I've done, I've made printouts of each of those equations. And I'm going to show you how to match up which equation goes with which graph. And actually it's not very difficult. The one key that makes it not very difficult, I want you to notice that none of these graphs have a phase shift. Remember, when you have a phase shift, the standard equation this phi here represents if you have a phase shift. If this phi is 0, then our equation looks like this, and there is no phase shift. So just a quick review, the A will be the amplitude, and this omega allows us to determine the period. So we will need to have those two things. So here's how I approach these. Basically, there are 3 questions I ask myself, or 3 things to look at to figure out which equation goes with which graph. The first question is, what happens when the angle is 0? In other words, when we go look at our graph, the horizontal axis is the angle. So if I throw up one of these graphs, first thing I'm going to look at, so here's the x-axis, which is actually the angle. So this is in radians. Maybe I'll get one that looks more familiar, where maybe you're more familiar with. 0, 2 pi, 4 pi. Well, right here is angle 0. And then this is the graph. The up and down is the value of the function, or the value of the equation. So what I'm going to do, very first thing, I'm going to take each of these graphs and see what's going on when the angle is 0. And it's a very simple thing I'm looking for. Here's what I'm going to look for. At an angle of 0, if the function equals 0, I know it's a sine. If the function is not equal to 0, then I have a cosine equation or cosine wave. And that's because if you think about here, I brought a copy of the unit circle. These trig graphs are based upon, well, I thought I brought a copy of the unit circle. But if you recall, for the unit circle, right here is the angle 0. This point is 1, 0. 1 is the cosine, 0 is the sine. So we know that when we start out at the angle of 0, the sine is going to be 0, the cosine is 1. That's what we're saying here. At the angle of 0, if we have a sine function, it has to be 0 at the start, where the cosine is not going to be 0. So for example, I look at this graph. All I'm looking at is what's going on when the angle is 0. Since my graph is 0, with the angle is 0, I know this has to be a sine wave. So I'm just going to mark. Matter of fact, I think what I'll do is quickly take each of these graphs, and all I'm doing is looking simply at what is happening when the angle is 0. Here's another one where the angle is 0. I know this has to be a sine wave, and therefore when I try and figure out which equation is which, look at this one now. At angle is 0, what's going on here? It's at 2. This is a graph where the amplitude is going to be 2, but you notice it's not 0. So I know this is the graph of a cosine equation. So very simple first thing to check. Here's angle 0. Once again, it's high. It has a value of 2. I know this has to be a cosine. So just for fun, let me quickly go through these. Here it's low, which can happen, but it's not 0. If it's ever not 0, we know we've got a cosine. If it's 0, we know we've got a sine. All right, look here. We're back at 0 now. So I'm back. This is going to end up eventually being a sine wave. Here, we're at -2. So I know this equation for this graph is going to be a cosine. And I got a few more. We're back at 0. Sine. And like I said, there were 10 of these. Oh, there's my unit circle. Here it's high. Cosine. Here it's down here. But since it's not, if it was 0, it's a sine. It's not 0, it's -2, so we have a cosine. So when you're doing these problems, one of the first things you can do is to know right away whether this graph is a sine or cosine. Matter of fact, I'm going to go ahead and just for now, I'm going to split these into 2 piles, cosine and sine, because as I'm trying to figure out which equation is which, I can right away narrow it down and cut about half the graphs up. So I'm going to have a pile of cosines, and the rest of them are sines. So that's going to help me, because you know what? As I begin to look at this first one, I know I've got my equation is a sine. I've already narrowed it down to, I think I have maybe 4 graphs that are sine graphs. So then I just have to say, well, which of the 4 graphs does this represent? So that's the first thing to do. That's a very simple thing. And this works since there is no phase shift. Because remember, a phase shift will cause this whole graph to shift left or right. And then this little test I'm performing now, this little check, will not work. So if there's no phase shift, and for this problem, in the homework in my math lab, it turns out none of these equations have a phase shift. So that's why I can check this. Now the next thing I'm going to do is, you notice some of these equations, of course the number in front is going to be the amplitude. So it turns out for all these equations, the amplitude is 2. So when we look at these graphs, you notice they all go from -2 to 2. That's very straightforward. But the key thing is I want you to see is that some of these graphs are positive and then some have a negative sign in front. So how do we know whether we should have a positive or negative? So the next thing we're going to try and determine is what happens is when you stick a negative, if I have a normal, let's look at a normal cosine. And if I were to just do a quick, very typical plot of a cosine. So when the angle is 0, cosine starts out. What's the cosine of a 0 angle? I found my unit circle. Angle 0 is right here. What's the cosine? It's 1. That's why it always starts, cosine always starts high. And then it goes to the middle, and then it goes low and back here. So here's one period, one cycle of a cosine. So you notice when you get to here, now you start repeating. So this is a standard cosine wave. And you notice this is positive here. What happens is, if you stick a negative in front of it, it's almost like we say you reflect around the x-axis. You take this graph and you just flip it over. So you can imagine how this ends up down here and here. Matter of fact, let me draw in what happens, and you can see. So this would be, a negative cosine wave. So here's what you can do. I can go to my cosine graphs, and if it starts high up here, I know I have a positive cosine wave. If when it starts at angle 0, it's down here, it's negative. So I can actually grab my pile of cosine waves, and right now I can quickly determine that. Here at angle 0, it's high, so this is a positive cosine. Don't need to add anything. Here, look at it, starts low. So I know this is going to be, the equation for this graph is going to be negative cosine. Starts here, high, positive, so it's a positive cosine. Look at where it starts at angle 0, it's negative. And it's high up here, so it's positive. It's down here, so it's negative. So by simply looking at, once again, at the angle 0 of a cosine wave, you can decide whether you should have a positive or negative in front of the cosine. What about the sine waves? Well, let's look at the standard sine wave. So a sine wave at angle 0 starts at 0, then it goes up, back to the middle. So here is a standard sine wave. So it goes up, comes down, and back here. So this is y equals sine. So what happens if we have a negative in front of the sine? Well, once again, if you can imagine rotating or flipping this graph, rotating it around the x-axis. So in other words, it's still at 0, except now we go here, 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 and here. So then it becomes, so this is the graph of the negative sine. So what do? Well, you go to, once again, angle 0, and if the graph is going up at angle 0, it's a positive sign. If it happens to be going down, it's a negative sign. So if I go grab my pile of, well, I know our sign, let's say this one. At 0, it's going up, so it's a positive sign. Look at this one. What happens at angle 0? It's going down. This has to be a negative sign. What happens to this one? It's going up. It's a positive sign. What happens to this one? It's going up. It's a positive sign. So 3 things to check so far. Both of them occur when the angle is 0. We can right away check and see whether we have a sine or cosine, and then we can see if we have a positive or negative in front. And then there's only one more thing to check, and once you check this, you will be able to figure out which graph is correct. And you simply determine the period. Remember, the period is t. So what I'm going to do now, let's just look through some of these. We'll start with an equation. Maybe to give you a better feel, let's maybe try and look at this problem to see how this is going to work. So look at this first equation. Here the amplitude's 3, but I think the amplitude's 3 for all of them. So it's a positive 3 sine of pi over 2x. First of all, since it's a sine, I know at angle 0, the wave has to be at 0, and since it's a positive sine, it's at 0 and going up. In other words, it can't be this graph, because look at it's high. It could be this graph, because look, it's 0 at 0 and it's going up. It can't be this one, because at 0, the graph is down here. It can't be this one, because the graph is 0, but look at it's going down. This is like a negative sign. Look at this one, at 0, it's high. That's going to be a cosine. Look at this one. Matter of fact, as I'm looking at these graphs, I can right away tell whether they're sines or cosines and positive or negative. Maybe I'll just do that real quick. What is this one going to be? It's high, it's positive 3. This is a positive cosine. This, it's 0, and it's going up. This is a sine. This one, it's at negative 3. That's a negative cosine. Here, it's 0 at angle 0, but it's going down. This is a negative sine. This one, it's going to be positive cosine. This one, it's 0 and it's going up, so this one is a sine. So since that's what I'm looking for, so far, there are 2 graphs so far that are positive sines. So 2 possibilities. We keep going. Look at this one, it's down here. Look at this one, it's also down here. So this is a negative cosine, negative cosine. Here, it's positive cosine. Here, it's 0 and it's going up, so this is going to be a sine. So there are actually 3 of these graphs that are positive sine. Maybe I'll just mark them here. So I've narrowed it down to 3 possibilities. Now, which one is it? Well, the period determines it. So this is my omega, pi over 2. So I go here. So for this problem, I put in pi over 2 for omega. This thing ends up being 4. That means the distance along the x-axis is going to be 4 when the graph starts to repeat. So let's see. So for this one, hopefully I'll try and focus it so we can see well. If it starts here and goes this far, that's 1 period. It's gone to 4 pi. That's not what I want. I just want 4, not 4 pi. So it's not that one. This one starts here and it goes to here. The period is 4. I think this is the one. Let's just see what this last one is. It starts here and it finishes the period here, and it's just a little past pi over 2. So it's definitely this one. So right now, I know that this is 3 sine pi over 2x. Just for fun, let's do another sine. How about this one? Negative 3 sine of 1/2 x. I need to go figure out which of these graphs would be a negative sine. So once again, it has to go through at angle 0, the function 0, but it has to be going down. So I see right here, it's going down. So this looks like it's a negative sine. Are there any more? How about this one right here? Nope, it's high. You know what? There's only one graph here where at angle 0, the function 0, and it's actually going down. So that means it has to be this one right here. So that one I was able to pretty quickly. I didn't even have to check the period. Let's do a couple of cosines. How about, let's do, this one's a little different. Y equals cosine, 3 cosine 3x. So first of all, I have to figure out which graphs are positive cosine. So positive cosine, angle 0, the graph has to be high. So here's a positive cosine. This is a negative cosine. Positive cosine, right, because it goes high. cosine, negative cosine, positive cosine. Looks like there are 3 positive cosines. Now all I have to do is just figure out the period. So my omega is going to be 3. So for this one, if I figure out the period, it's actually 2 pi over 3. So I'm going to look at these 3 cosine graphs and see if the period is 2 pi over 3. So this one starts up here, it goes down, it goes back up. It looks like the period's 4 pi. So it's definitely not that one. This one starts up here, looks like the period's 4. So there's only one left. So here it starts high, and you can see here it goes up to here, but from here to here is pi over 2, and then I believe each one of these hash marks is like pi over 3 or pi over 6 maybe. Anyways, you can see how this right here is actually 2 pi over 3. Yeah, this is broken into 6. So this is 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3. So this is definitely that graph. So this is y equals 3 cosine 3x. And we'll do one more. How about a negative cosine? How about this one? Y equals negative 3 cosine 1/2 x. So let's go find the graphs that are a negative cosine. So that's going to be where angle 0, it starts low. So right here is a negative cosine. Right here is a negative cosine. Another negative cosine, because at angle 0, it's down here. I think that's it. So once again, 3 possibilities. They're all right here. Which one's correct? We have to look at the period. So the omega is 1/2. So if I go here and calculate my period by plugging in 1/2 for this 2 comes up and ends up being 4 pi. So the graph of this should have a period of 4 pi, so it should complete one cycle in 4 pi. So here, first possibility, it starts down here, goes up, it comes back. When it gets down here, it's finished the period, which is 4 pi. Looks like that's it. Just for fun, let's check at the other periods. What's the period for this one? Starts here, goes up, comes back. The period for this one's 4. Period for this one, it's definitely not going to be 4 pi. So it looks like that's the one. So now I can say y equals negative 3 cosine 1/2 x. All right, so these actually aren't too bad. So once again, here's my suggestion how to figure these out. You look at an equation and you see either have positive or negative cosine or positive or negative sine. Very easy to look at the graphs and see which is which. So once you narrow it down, then you simply grab the omega from the equation, calculate your period, and then that should narrow it down to just 1. So these kinds of problems are in the homework quizzes and maybe even the exams, so it's good to understand how to do these.